Okay. So today we will review and solve the practice test for integration. All right. So in this practice test, you have 7 questions, I think I will have one more for you as bonus, right? As usual. So, but let me make a short theoretical review first, right? Okay, please tell me, what have we learned in this chapter?
Area problems.
Area problem, right? And what else?
How to find the like original function.
Yeah, how to recover the original function, right? If we know its derivative. So, okay. So, there is 2 motivations in this chapter, right? The second problem, we don't have any integral limits, so we study antiderivatives, right? Antiderivative, just f(x) equal to antiderivative of this guy, and this is equivalent to that, f derivative equal to fx. So this is called antiderivative, and usually when you have antiderivative, you might add c, right, constant to that, because when you take derivative of constant, you get 0. So derivative of this guy, or f of x plus c, is almost the same, right? It's same. For the first problem, the area problem, please remind me the process. So suppose we have a very good function, which is continuous and then non-negative on some interval. We want to find area, right, of the region enclosed by the graph of this function on some interval a and b. Okay, so how to do that? Let's remind me the process, because on the final exam or on the test you have one problem like that, right? How to approximate the area using Riemann sums, right? Using Riemann sums. Okay, please tell me the process. Just the main idea of solving the area problems. The main idea, how to do that.
Just split the area into any sub-area.
Yes, we have to split the area, right, into n sub areas. Of course, we can do differently, but again, in this course, we suppose that all sub areas have the same width, right? All means we have to split the interval a and b into n sub intervals, right, of the same width. It's easier for us, but in general, we should not do that. Make sense? And then we have to find the area, right? We split this into n sub area, sub region, and for each sub region we have to find some approximation using whatever we want, right? Using rectangles or trapezoids, right? Is that correct? But we learn rectangles, right? We learn rectangle. So for each one, we learn rectangle, and if you pick any point, arbitrary point from here, right? And you make some rectangle here, and you use this rectangle to approximate this region. So the area of this rectangle is some estimate of that area, right? So what is the area of this rectangle? That is, suppose this is xi star, so here should be f of xi star, right? And then the area of each one is equal to delta x times xi star. Is that correct? On the I interval. Makes sense? And then you sum them up. You sum them up, right? You get some sum, right? And sum I runs from 1 to n, okay? So you have some Riemann sums. some Riemann sum, okay? You have some Riemann sum. And you know, the last step is we have to do a limit process. A limit process. We have to turn n to infinity. Or sometimes, but in our case, because all subintervals have the same width, and we say, yeah, delta x goes to 0, right? It means we increase the number of subintervals, right? And then since we increase the number of subintervals, our errors in here and in here will approach 0. Makes sense? This is why we can get an exact area of our region. So we have limit n goes to infinity of this Riemann sum delta x, okay, or sometimes delta x goes to 0. And that is your definite integral, right, of function f on the interval a and b, and this is the exact area of this region. And of course, in this case, our function is non-negative, so we are good, right? We are good. Makes sense? And that is all about this chapter. All about this chapter. So the rest of this chapter, we study techniques how to evaluate definite and indefinite integrals. Okay, so we have power rule, we have substitution, right? We have power rule, we have substitution, I think, and we learn integration of exponential and logarithmic functions. Okay, so you have formula sheet, integral tape. Yeah, stop by my office for that. So you have that, okay, try to learn, practice a little bit more, and then, you know, get some idea about it. Now, this picture, you know, is general. Now let's remind you some basic different integration rules, and then we will solve practice problems in here. The first rule is the power rule. Power rule, right? Power rule say, yeah, if you have some function x to the p dx, in this case, I say p is not -1, different to -1. This is equal to x to p plus 1 over p plus 1 plus c. And when p is equal to 1, you have dx over x, right? Equal to -1. So what is antiderivative of dx over x? We just did it yesterday. What's that? ln absolute of x plus c, right? Okay. So the first problem in this practice test is find the indefinite integral dx 5 over x. Okay. So since here phi is a number, we can bring that out of the integral. You have 5 dx over x. Get it? So dx over x is ln of absolute of x. You are done. So if you remember this, you can solve in 30 seconds. Agree? So this is one form of the power rule, right? One form of the power rule, where when power is equal to -1. The second problem, also on the power rule, find the definite integral of 5x squared plus x plus 6 dx. So in here, you know, we have one property: when you multiply a function by some number, you can, you know, just evaluate integral of that function with that number. And in here we have sum of three functions, right? We know that when we integrate sum or difference of functions, we may just differentiate separately, right? All functions. In this case, we can find all antiderivative at the same time. So if you write in here, right, I have 5 dx squared dx plus x dx plus 6 dx. Right? The 6 dx. So for this integral, we use the power rule. We have 5. Please tell me the answer. Wait, what? X squared. So according to the power rule, what's that? X cubed over 3. Okay, and then plus. What's this? X. The power is 1, right? So you have x squared over 2, and then 6x, and then don't forget c. Done, right? You can simplify. Oh, yeah, it's nothing to see. Yes.
It's the same thing as if you did 5 over 3 times x squared plus x over 3.
Oh, yes. Yes, 5 over 3 or 5 times x cubed over 3 is the same, right? Yeah, so you have 2 problems on the power rule on the test, but you know, I picked 2 easy ones. If you remember the quicks, the last quicks, we have 4 problems on the power rule. You remember that? In fractional, in radical forms. So, but these 2 problems, you know, are pretty easy. All right. The third problem, find the indefinite integral of the following: a cosecant square x minus 3 sine x dx. So you have one problem on trig functions, right? On trig functions. Again, here we have to memorize something. We have to memorize something from differentiation rule. So we split these functions, right, into 2 functions. So when we write this integral in the form a integral cosecant square x minus 3 sine x dx. Okay, so here we have cosecant square. Basically, you need to remember sine, cosine, tangent, cotangent, right? Antiderivative of sine is negative cosine. Antiderivative of cosine is negative sine, right? So derivative of tangent is secant square, right? So that means tangent is antiderivative of secant squares, right? Derivative of cotangent is negative cosecant square, right? That means antiderivative of cosecant square is negative cotangent. Is negative cotangent. Make sense? So that is negative cotangent. I have negative a cotangent x. And 3, we know antiderivative of 3 is negative cosine, right? So I write negative cosine here. And don't forget parentheses. So you have a cotangent x plus 3 cosine x plus c. So basically, you have trig functions in here, but you know, again, you need to memorize differentiation rules for 4 basic trig functions: sine, cosine, cotangent, tangent. That's it. I don't ask you too much about that. Make sense? So if you remember all this, you can solve for 1 or 2 minutes. That is the third problem. The fourth problem is on recovering functions from its derivatives. Okay. We have f second derivative equal to 4 cosine x f the first derivative at 0 is 2, and then the second initial condition at 0 is negative 7. So we have to recover our function. In this case, we have to recover the original function from its second derivative. Okay? Let me remind you about this, right? So if you have some function f of x, you differentiate, you get f the first derivative, right? You differentiate one more time, you get f second derivative. Or you can do that how many times you want, right? And what is integration? Integration is the opposite process. So you go from second derivative, you integrate, you get the first one, right? And you integrate the first one, you get the original function. Makes sense? But each time when you integrate the function, you will have a constant. You have a constant. Because antiderivative is a family of functions, not only one, right? And they are different in constants. Makes sense? So we have to find that constant. In order to find constant, we need at least an initial condition, right? For each step in here. For example, if you go from second derivative to the first, you need one initial condition for the first derivative. Makes sense? Initial condition. So that's why you need this condition, you see? This condition works for this step. And the second condition, you already have the first derivative. You integrate it, you get this guy. But for this guy, you need one more initial condition. And that is the second one. Get it? So in order to solve this problem, you have to integrate twice, right? And you have to plug the initial condition twice. Agree? Okay, let's do that. Now I have the second derivative. I have, that is what? That is 4 cosine of x. So let's integrate 4 cosine of x to get the first derivative. What is the first derivative? That is antiderivative of the second derivative, right? That means antiderivative of 4 cosine x dx. Get it? So 4, that is just number, we can bring it out. So I can write 4 times in here, and then cosine x dx. What is antiderivative of cosine? Sine, right? So I have 4 sine x, and then plus constant, plus c. Alright, so that is our first derivative with the constant. Now it's time to use the first initial condition. Yes.
So when you integrate, it's not a negative sign? Like cosine is not negative sign?
No, wait. You see, if you want to check that, you take the derivative of sine, and you get cosine. Derivative of cosine is negative sine, but antiderivative of cosine is sine. Get it? If you are not sure about that, you just differentiate your answer, and then you get the same, you are good. Alright. So now, I have to use my initial condition for the first derivative, right? I plug 0 into this function and set it equal to 2. From here, I know f derivative at 0 is 2. Then we have 4 sine of 0 plus c equal to 2. You see, I just plug 0 into the function, I get that. And sine of 0 is 0, right? That means c equal to 2. From here, I have f of x derivative equal to 4 sine x plus 2. Okay, so I can fill this chart, I get that is 4 sine x plus 2. And now in order to get the original function, I have to integrate one more time, right? I have to integrate one more time. I have f of x equal to integral 4 sine x plus 2 dx. So I can write here, let me save space. I will write here, okay? This is equal to 4 times sine x dx plus 2 dx. And now you see this thing. This is your negative. So now antiderivative of sine is negative cosine. Because cosine derivative is negative sine. We have sine here, we have one more negative. So I have this equal to negative 4 cosine plus 2x plus c. That is my function with the constant, right? With the constant. And of course we need to determine the constant. We need to determine the constant using the initial condition for the current function. Make sense? So now you plug 0 into this function and set it equal to negative 7. Negative 7. I will erase this part, okay? F of x0 equal to negative 7. So I have negative 4 cosine of 0 plus 2 times 0 plus c equal to negative 7. And what is cosine of 0? 1, right? Cosine of 0 is 1. So I have negative 4 plus c equal to negative 7. From here I get c equal to negative 3. And I plug negative 3 in here, right? Into this formula. I get the function is equal to negative 4 cosine of x plus 2x minus 3. That is my final answer.
I
Yes.
keep getting mixed up on the symbols, like if it's negative or positive. Like whenever you transfer the sine and cosine, because
Yes, I understand that. But again, right, I tell you, the only way, if you are not sure about that, you can check. For example, antiderivative of cosine is sine, right? Why? Because the derivative of sine is cosine. Get it? Antiderivative of sine is negative cosine because the derivative of cosine is negative sine, right? But you have sine here, that means you have to add one more negative. Get it or not? Let's say cosine derivative is negative sine. Or I say, yeah, negative derivative of cosine is sine. Agree? So that means antiderivative of sine is negative cosine. Are you good with this? So, if you remember our steps how to solve this, you can solve this in maybe 3-4 minutes. Agree? Okay, 5 minutes. Now, this problem maybe is not good for you. This say use the midpoint rule for n equal to 4. So let me remind you about the Riemann sum. I from 1 to n f xi star delta x, right? That is Riemann sum. And when you take the limit of this Riemann sum, you get the exact value of definite integral, right? So that means when n is big enough, this is approximately equal to integral from a to b f of x dx. Okay? So sometimes you get very complicated functions. So we may use Riemann sum to approximate that integral. Make sense? And this is what they ask you to do. This problem, they ask you to do that. If you still remember, here xi star is any point in between, right? subintervals I, the I subinterval. So in each subinterval you might choose the midpoint here, you might choose the left endpoint, you might choose the right endpoint, right? Or you might choose any point you want. Make sense? They ask you about the midpoint, but probably I will give you left endpoint or right endpoint, so you don't have to worry about midpoint. Anyway, I will tell you how to do that. So if you use left endpoint, what is the difference between left endpoint and right endpoint approaches? If you use left endpoint, your sum will start from where?
0.
From 0 to
And
n minus 1, right? Each time you use the left endpoint. In the first part, in the first interval, you use 0. Or in the last interval, you use xn minus 1, right? So that's why your index runs from 0 to n minus 1. If you use right endpoint, your sum will looks like I from 1 to the end, right? To the end. So you have to remember that. And then what is the midpoint? Midpoint xi equal to tell me, if this is xi, this is xi plus 1. So how to find the midpoint? So you just take the average, right? Average. The average. So this is what? Xi plus 1 plus xi over 2. So that is your midpoint. Agree? We can find all those points, once we get delta x and number n. Get it? But okay, let's do for left or right endpoints. So don't spend much time on the midpoint. For the left right endpoint, you have the same approach. First, we need to find delta x, right? What is delta x? Delta x is b minus a over n, right? Where n is the number of subintervals, a and b is the interval, right? B minus a is the length of that interval. Since we have n subintervals of the same width, so we use that. And then what is xi? Xi is equal to x0 plus I delta x. Okay, I delta x. So that is all about the Riemann sum, right? Let me write the functions in here and we work together. The function is f of x equal to sine of pi x. AB is 0, 1. Okay, I will write here. That is AB. And then the number n is 4. Okay, I'll show you how to use left endpoints, right? And then you do that for right endpoints. Agree? But on the test, I may ask you about left or right. Get it? So if I use left endpoint, I just copy the formula over there, right? I just copy the formula over there. I get the Riemann sum with the left endpoint for n equal to 4 equal to sum I from 0 to, if n is 4, so n minus 1 is 3, right? N minus 1 is 3. And here I have f of xi times delta x. First thing I want to see in your solution is the Riemann sum. Alright, right? And next, you have to find delta x. What is delta x in this case? Delta x is equal to b minus a over 3 or 4. Over 4, right? Because n is equal to 4. So that is 1 minus 0 over 4, which is 1/4. Agree?
You said it's b minus a over what? Okay, over n.
Okay. Over 4, right? So 1/4. And then I calculate. First x0. What is x0? X0 is 0. X0 is a. X1 is, alright, I write x1 in here. x0 plus 1 times delta x, right? Because xi is equal to x0 plus I delta x. Is it correct? So I have 1 times delta x is 1/4, that is 1/4. x2 is equal to x0 plus 2, 1/4, but x0 is 0, so that is 1/2. Make sense? x3 equal to x0 plus 3, 1/4, and that is 3/4. If we use left hand points, we don't have to find x4. Because we will not use x4. Makes sense? Anyway, x4 is 1, right? The end point. x4 is 1. And now you just plug all numbers into that sum, into this sum, and get some approximation. And now the Riemann sum with the left hand point for n equal to 4 equal to x0 plus f of x1 plus f of x2 plus f of x3, everything multiplied by delta x, right? But this is another form of this guy, right? I runs from 0 to 3 to 3, right? So you have this. And now you plug all those numbers xi into the function. Your function is psi of pi over 4. So pi over x, pi x. So here x0 is psi of pi times 0. F of x1 is psi of pi 1/4, right? I don't do something special, right? Just plug number into function. x0 is 0, x1 is 1/4, x2 is 1/2, x3 is 3/4, delta x is 1/4. Get it? So your remaining job is just calculate function values. So here we have 0, psi of 0 is 0. Psi of pi over 4 is square root of 2 over 2. Psi of pi over half is 1. Psi of 3 pi over 4, again, square root of 2 over 2, right? Times 1/4. So your answer, if you simplify this, square root of 2 over 2 is 2 times 2 with 2 will be cancelled out. You have square root plus 1 over 4. And that is, approximately equal to integral from 0 to 1 psi of pi x dx. When n is equal to 4. Of course, when n is small, we might have very big error, but that's what they ask us to do. Okay? That's what they ask us to do. Any question for me? So that is the 5th question. I suppose you may use 5 minutes to finish this. Maybe you can do faster. You can do faster. No? First, just copy this formula, right? For the left or for the right. It depends. If you use the left hand point, I runs from 0 to 3, right hand point runs from 1 to 4, right? Do all this step is the same. Make sense? Delta x or xi. And then you just rewrite this sum in this form, in an explicit form, right? And then just plug the numbers into this function value. You're done. Alright? Now, I just want to ask you, because we have integral from 0 to 1 psi of pi x dx. Can you evaluate that integral? Exactly. Can you do that? Evaluate this integral exactly. Find the exact value of that definite integral. Sine pi x dx. Can you? Yesterday we did many problems on substitution. Here pi x, that is not good. We don't like that, right? Do you remember this situation? Cosine 2x, sine 2x. So we have a composite function over there. Is that correct? So if we have a composite function, we need to do substitution. Right? We need to do substitution. What's substitution in this case? So we know we put the inside function, right? Is equal to, just put that equal to u. The inside function is pi x. Get it? So if you put u equal to pi x, from here you get du equal to pi dx, right? And you have to rewrite the original integral in terms of u. And we have two ways to do that. First, we find the antiderivative of this guy, and then at the end we plug 0 and 1, right? The second way is we do substitution and then we change the interval of integration right away. Make sense? So, but I recommend you to do in the first way, because you don't have to do much computation, right? Just find antiderivative of this and then plug 0 and 1 into the end, into the function at the end. So you have du equal to pi dx. You solve for the x, you get dx equal to du over pi, right? And then you rewrite the original integral without integral limits. So we have sine what in here? Sine u, right? Sine u. Dx is equal to du over pi. And then you have 1 pi sine u du. And now what is antiderivative of sine? Cosine again. Negative cosine, right? Antiderivative of sine is negative cosine. So I have negative 1 pi cosine of u. And then plus c. And now I will evaluate from 0 to 1. But I have to plug pi x into this expression. So I get negative 1 pi cosine pi x plus c. And then my integral from 0 to 1 sine pi x dx is equal to negative 1 pi cosine pi x evaluated from 0 to 1. That's it. You see, and then you plug 1 and 0 into that, you get negative 1 pi cosine of pi times 1 minus cosine of 0. Then this guy is negative 1, right? And this guy is 1. So you get negative 1 minus 1 is negative 2. With negative 1 pi, you get 2 over pi. You see? That is approximately equal to 2 over pi. 2 over pi is the exact value of this definite integral. And we use Riemann sum to approximate that number. And we have this answer. Is it good? Any question for me? Interesting. We just did that in the last 2 lectures and it seems to be new to you. So just go ahead. All right, we still have 2 problems and 10 minutes. I try to solve 2 problems in 10 minutes. The first problem is find the indefinite integral by substitution. So I think this is now easy for you, because we did many, at least 8